All right, so today we try to show you an example, very simple example, on how can we develop an app, MATLAB app to calculate shear force of bending moment diagram. So to go that, we leave the scripting and we go to app, and then we can click on design an app. Tap and then extend that, and then you can see two-panel app with auto reflow. So there are a couple examples. So as well, you can go through it. So the one we're trying to generate here, it's we click on the new app, and then we can see, let's define. Here you have the components library where you can drag and drop and different components, lamp, switch rocker, toolbar, slide range, and other things you could use. You feel you're welcome to utilize for your app assignments. So first of all, we need to design the question, and then we can bring that, because the app allows you to bring an image, as you can see it here. So I will go to PowerPoint slides and then try to create an image, very simple image, insert from shapes. We'll insert that bar or a beam, and then I could put a support reaction at that beam, at that end, and then here I could as well Control-C, Control-V. So one is using roller, the other one could use something. We could Control-C, Control-V. Okay. And the last one, you can put it here in the middle. And here we can design support reactions to be in that way. You can change the colors, of course. You are welcome to do and try any of these requirements you want to do in this type of examples. You're welcome to generate the question how you feel will work for you. So these type of questions are very important for us to determine the support reaction. Let's say I'm designing here a question when I have a point load at some location. I will sketch the lines to show where is that location. You can use disconnected line, and as well here we could use something. Based on that equation, I will have support reaction at this point. I could increase the thickness of that, make it 5 as an example, just to make the app clear. People can see it clearly. And support reaction, by the way, there should be a support reaction in X and Y direction, but I'm showing just the Y direction as for the support reactions. And in case we can label some of the distance based on what it's giving to us. Use a text, enlarge the size, so A is in meters. If the size is very small, you can always increase that so it can be visualized nicely in the app. And the same thing, the total length for that. So we can put this one here a bit, and then this shift up. And then we take the arrow, and then the distance between the two support reactions is represent for me the total length of the beam. So that we call it capital L. Of course, we need to name some of the components. Here we call it force, and that could be in the units in kilonewtons, and as well Control-C, Control-A. Here support reactions, we call this one RB, support reaction, and this point we call it RA, support reactions. Okay, ignore all. So I designed the app and all the images, print screen, or I can save that image, and then I go to Paint, and then from Paint, bring the image file, save as PNG image, and I call it Shear Force for the app. Right, so I go back to my MATLAB, where is the app is there, and I can now start developing the app. So the first thing we could start with is the tab group. The tab group you drag and drop, and it's giving you tab and tab 2, and then you extend that to represent for you tab and tab 1. So I go to tab the first one, I change the name for that one, I call it Shear Force. And you can see every time I make any changes and the components browsers, the changes will appear. So instead of tab will be, as soon as I enter, click on enter, will be Shear Force tab. And then that one, I call it bending moment. And you can see here will be tab to bending moment tab. All right. Make sure to go back to that tab, and you can see when I click on it, it will be highlighted here because you don't want to work on the other tab, and then it's very common things you can do. First, I'll drag and drop the image. Browse, I'll go and find the image which I just developed, which you can see many different images you could find here. Let's see, where did I save it? I saved it somewhere here. I think this one. Shear Force. I think so. Yeah. That should be good size. You can adjust it on how you want to show it. And then that's a good size for people to see it. Okay. So you can even centralize that image on where you want to do it. After that, I need to do the inputs. So this for this shear force, the browse an image, I could use edit field numeric here, and I call the first one F, which is the force we're trying to use, and kilonewton is the unit, so people can understand what they're entering. I could change the color of that or use different even style. You can address here whatever things you can try. And then I could bring another one. So that is my input for it. So the input data, edit field, second one, let's say I put them randomly here. So that one would be L, the length in meters. And then as well, I could just highlight it. I use the wrong brackets just in case. Okay. And okay. And now another field tab I can bring here. I will show you how to align them nicely. So that is for the A distance, for the force, and where it's located. Okay. So I found these for not really aligned nicely. I'll show you how can we align them nicely. But before that, I need the push button, which is that one. To work on it, I will change the name of button to call it calculate. Again, I could change the font size to make it, for example, 18. I could change the color, something different. It's up to you. And even the background, I could change it to be different. So something you want to explore at any time. So this one, you can see them, they are not aligned nicely. I will select them, and then I will get the option by aligning them that way or center, and I can move them by the right or left, and as well I can apply vertical or apply horizontal, or as well to have the same distance. So apply vertically, it means you have the same distance between them. So that is for the input information. Now what will be here will be output information. So that will be calculating for us the resultant support reaction or support reaction RA, and that will be kilonewtons. You see everything I'm adding, it's showing up at some point here, and then I bring the other one, which is the support reaction B, units kilonewton. Units are very important, but if you want to work in multiple units, so then you can design something to work in different units as well. Okay, and you can also use text if you want to add some information, text area, or you can, if you don't want to use that text area, you can use label. So label, like you can add your name or you anything you want. So NG6039 example. Again, you can write information, change the color, like anything you find you could benefit from this example, you can just try. I'm just showing you different ways of trying the example. Okay. The things we want to produce as well is the plot. So we want to plot the shear force diagram. You wait for it to get level, and then I can extend it to have a nice. You can add, with this edition, you can add the title. So shear force diagram. X represent for you the L in meters, and Y represent for us is the shear force in kilonewtons. Okay. You want to change anything about this plot, of course, you can click and change the colors. But also, if you want to add, for example, the grid and some stuff interesting for you, so I could add the grid in the X and Y direction to make it that's nicely for you. After I finish this app, which again, you can adjust it on how you want it to be, look like, colors and everything, I go now to the second tab, which is the bending moment tab. And in the bending moment tab, I'm just showing it as example. I need to push, but I'm here and I say here, plot bending moment diagram. Okay, and from that bending moment diagram, I bring the x-axis and then I will centralize it, change the title to be bending moment diagram, and x represent for me L in meters, and y represent for me moment or bending moment. And the units for that is kilonewtons meters. All right. Again, you could activate the grids in the X and Y. Also, you could font to increase the font for this figure. And the same thing you could apply for the push button for the apply information. Okay. And that way you can have a nice plot. Okay. So as you see, this is the tab which is called in the MATLAB app is the design. So we design everything in it, but technically, if I try to run the app is not connected to anything. First of all, I need to save the app. So I'll call it Shear Force Bending Moment app. Okay. That one, if I want to run it, doesn't have anything. So if I enter the value here, 20, 30, the length, A is 25, calculate, nothing happening because I haven't done or scripted the code. The code is, as you can see it when you start the app, it's locked and nothing is there. So we just were doing the design view. Now we need to code the app in that way so we can have everything go through it. So first of all, the first thing, when I enter these values in the force, the point load, and as well the length of the distance between, or the length of the beam, and the distance where is that force located with respect to one point, which is A, support reaction A, I right click on the calculate and callbacks, and we could add the bottom push function callback. Now I can see it's allowing me to update the functions and that one. So I'll start with the following. So F equals app. This is kind of like something with the app, FK, which is the force kilonewton, edit field, which you can see it under the calculate button, what we're trying to do. And here we are saying, I want the value. And that value is mean this, what would be the value for it. L, you have equals app dot, and then we'll ask you what you're trying to define here. So I would say it's actually LM or LM edit, which you can see it here. And that will be as well value, because we're trying to identify that value for it. And the last one, A equals A, the app itself, dot an A M in meter edit field, and that will be as well the value. So we're telling the MATLAB script or the app, FLA, I need to enter them as a value. Now we need to write a comment, calculate support reactions. So to explain that to you, we define what are these F kilonewtons, LM, AM. Now the calculate, we need to calculate for me support reactions. Technically, I need to enter the equations to calculate for me. RA from mechanical engineering equals the force times L minus A, all of that divided by L. Remember, what is calculating must be defined. So the force is defined, L is defined, and A is defined. Who's defined that? When I enter the values in the app. And then I write RB equals will be the F times A divided. So kind of like this is easy to take a moment around the point, and then summation of forces in the y direction equals to 0. Now, these two equations would determine for me the support reactions, but now I want these support reactions to be output here in these boxes or these steps. So I go there and I need to define that in the opposite, so app. So here we started F equals app. Here is F dot, and then I'll say what we're looking for is the RA, and that will comes to us, which is RA kilonewtons edit field, and then we say you put the value here equals to what's RA. So technically what we've done here to say whatever you calculate from that script, you put it in that tab or field. Same thing, app.rb kilonewton field, yes, and we bring the value, and that value coming from where? From RB, which is just calculated. And then we save everything and we go and see how we test the app. So when I test the app here, I'll say I have a support reaction is 10. Let's choose the length of the beam is 5, and A is in the middle. So A is 2.5. It means the point load is acting in the middle. And then by logic, that will be 10 divided by 2. Like kind of the support reactions it's going through it. Now it's giving me an error because it's something I have missed or I haven't identified. Yes, that should be RB capital because it's technically didn't recognize that small letter. Now I go back again and try it. So it's the app, it can give you some of the calculations if it's correct or wrong. Here is 5 and here is 2.5. So technically that is load in the middle. So the support reaction giving 5 kilonewtons from each side to make sure it is balanced. So it's working now, no problems. Even there was an issue, the code will try to help us to generate that. All right, so now I done this. Now what's next is how can I plot the command for that? Because that's one of the most important things. What I need to do for a plot, I could add another one, which is push button here, and I call it again plot shear force. You can define it, shear force diagram. You can locate it or center it, make sure you can change it, miss the edge, shear force diagram, change the colors if you want. Yeah, you can explore all of these things. Like it's something you can change the font size, Maybe 18 is too big, make it 14, and you can go through it. So that one, it's the push button. One was for calculate, this one is for plot. So I can generate the plot here. So to do that, I right click on this callbacks app, add push button function callback. So I will come here and adding two functions. So I'm using very easy way. I don't want to complicate things here. Again, what we're trying, we want to define the values first. What is F, what is L, to make sure the app understand them. And also we need to bring the calculations so it can generate for me the values. So kind of like repeat this. By the way, we could done it here, but I want to separate them at this stage so we learn them step by step. Now, we want to generate the plot. So x equals the range for it. It's from 0, and to get really nice values, 0.01 till what will stop till L. So if L was 10, then will be 10 meters. If L was 3, then will be 3 meters. That is my range. Shear force equals RA times, and here are some equations for it. So it will be X is smaller than 0 minus F, and times here will be X is smaller than A, and then plus RB when X, open brackets, X is bigger than L. Capital L must be, because to match that. So that is just the equation to determine for me the shear force. Now, of course, I need the command of plot. And to plot here, I need to be careful with it. You have two different plots. One is plot UI axis for the first plot shear force. Another one UI axis 2 for the bending moment diagram. So I need to be careful which one I select here. So I will be careful here, app dot, and then when tell me what exactly, yes, I need that YUA axis. And then comma, we're plotting X with respect to shear force. The X represent my and the shear force on the Y, and then I could choose M, and then that will be to make it very clear, line width, we could set it up to 3. So you can see that line nicely on the graph. Line, something for the app in the command, we could use it to make the X's goes nicely. We can add the following lines, len app dot UIX X's, and then here would be square 1, sorry, X1 to X till the end, and that one will be closed when it's 0, 0. So that is also to add the origin point. If we want to add, because shear force needs like where is the origin for the line, and then we have the X's app dot UIX says, and that will be to be fill auto. Right, we go there. So this is the app, it's finished and all good. We save. Let's test it. If something wrong, I will get an error. I'll try to fix it. Very simple. So we get here, we click run, and we have, let's say we want a point load in the middle. So 10 kilonewtons the point load. The beam is 6, and the A acting, or the distance of the beam, is 3, and calculate, so 5 and 5. And when we click on plot shear, there is something we missed here. That's where we need to fix. So always, that's why I say, if something is mixed, like we missed, we need to identify here. Shear force is equals RA times X bigger than 0 minus F. X is bigger than A plus RB. X is bigger than L. I don't think it's something we missed, but let's check. RB, A, X. It's saying I use capital X somewhere, and it should not be capital X. is saying unrecognized function of x. So there is an x used here. It's x is from 0, 0.01 to L, x, that x, see, I didn't see that. I put a capital X, and that's what caused the error in that script. So it's good to see these comments because it can show you where I missed it. Now we can run it again, and let's try it. So we say it's 10, 6, and 3. Now you see, because I use auto there, it doesn't show at the moment 6 meters, but when I run it, calculates 5, and when I plot, see carefully to the shear plot, it should go and show 6. Did I miss something else? There is error using shared point push, you undefined S. So right, that should be not S, should be X. Yeah, X and good. It's good. It's picking up all the errors, and it can tell me what did I miss. Again, 10, 6, 3, calculate, and then plot. And that's what I'm trying to show you. So it's successfully plotted for me. It's going up by support reaction 5, and then the point load is pushing in the middle 3 to 10, which is negative from 5 to -5, and then goes here, and that will go up to that value. Awesome. So that is work with no issues for the app. Now we can come for the second one, is how can we plot bending moment diagram. So I can come here and right click callbacks function, and now I get a new function for the bending moment diagram. So the same thing what we done for the shear force, we can duplicate here, but we need to be very careful what exactly we're trying to do. So to save my time, I could really copy everything we done that one, because that is the same information we need to calculate. Is the force defining all these values, because all this coming from it. The only things changing here is the equation for bending moment state of shear force. Bending moment equals, so RA times X minus F, and that one times, be careful, don't miss that, X minus A, close the brackets, and then times X bigger than A. All right. And then for that will come as well for me is to plot the y and x axis. So I could really just bring these commands and I can adjust to them to save my time. So will be plot UIX. So instead of UIX, that one, I need to change it to something else, which is UIX2, because that where it is, X will be respect to bending moment. Because remember, I'm doing the UIX2, which is the bending moment, and that will be M line width 3, which is okay with that. And here again is UIX2, and that one will be the last one as well, UIX2, because those are different from the other one. Otherwise, we'll get some errors. Click save, and let's test it again and see, make sure like everything is working with no issues. If something is wrong, I can come and see where's the error and try to fix them. Right, we tested here. We go back to the example. So 10 is the point load, 6, let's choose 7 now, and then when it's like about 4A from that 7, we did calculate the support reaction. We plot that support reaction, so acting at 4. And then when we go to the bending moment, we do the calculation. So obviously I have an error. It's saying to me something is the incorrect dimension for the matrix, because sometimes this will cause me an issue. So if I have the matrix is not operating right for it, so I could use that dot here as stated here, check that the number of columns. Now I think it's fixed this one. And let's try it again. See, it's good and very helpful, because if I miss something, if the matrix is going through it. So again, 10, 7, 4, calculate, draw, go bending moment diagram, and then I get the bending moment diagram calculated nicely for the for this equation. Very nice. Now, one thing could come to you and you say, hey, I want this app to come with a startup function app to call back and everything. So if I want this function always to start with something with the values already existing, I don't want to enter every time the values. You can come to here and you can click on callbacks. So you come to the top of the app and right click, callbacks, add startup function callback. What does mean that? I can set the values for the app to start with. So let's try it. So callbacks, add startup function callbacks. It's telling me what you want to enter. So I would say, hey, if equals 10, the values, so I'm giving it the values, L equals 4, and A equals 2. So I'm just giving the values to start with. So that's technically, as soon as I run the app, these values already stored in it. So app dot, and here we need to define every one of them. F kilonewtons, edit field dot will be the value, and that will be equals to F. And then we repeat the same thing. A dot like will be L meters edit field. This will be with respect to value that equals to L. And app dot AM with respect to the value, and that will be equals to A. So that is mean the values we just defined earlier in the script here, they will come to the app. So when we run it, we'll always go through it. Now, if you want the app to also produce the support reactions, I could copy this line, which can calculate for me support reactions, and then bring them here. And if you say, hey, I also wanted to actually not just calculate support reactions, I wanted to plot the shear force bending moment diagram, we say, okay, you can do it as well. You can bring this as well as a startup function. And that way you have everything as soon as you run it to go through nicely. So when I click run, you see everything is start up with the values. As soon as I click plot, very quickly will plot for me because the call up function is ready to perform that task for me. So I didn't need it. So these are the values I entered earlier as an input, which to start the function. And then here I just click and then we'll go through it. So that is the app itself. Now, I want to compile this app and then I can send it to people or anything I want to do with it. So designer app, you can just click on share, and share, you have web app, standalone desktop app, or whatever MATLAB app you can select, and then it will tell you here what you want to do. You can write your name, the email, the company, some description about it, and then package. When you package, technically you can send this app to anywhere and you can run it nicely with no issues, and you can test it anytime. So I click on that Shear Force bending moment app. It's already saved, and now I can send it to anyone. One thing I experienced with it, you should not have it when you run the app under MATLAB on the same command, because otherwise we'll not go through it. So you come here and install app. You can find that shear bending app, open, install, and then you come here and you find a shear bending app, and it doesn't work here. What I find it, change the directory for that and make it like, for example, desktop. Just temporarily select that folder, and then you come here and you say, let's run this app, and will work with no issues. You can see it here because it doesn't like to connect with that. And here, calculate and shear force bending moment diagram, and that one will plot for you. That's all for today. Thank you. I hope you enjoyed this tutorial about generating or creating a MATLAB app for shear force bending moment diagram.